ready to look at some examples involving mass from density. So in this first example, we can assume that we have a rod that is 3 meters long, and we're going to let x represent the distance in meters from the left end of the rod. If we suppose that we can then say the function f of x equals 1 plus 5x represents the density of the rod in grams per meter at the point x, suppose we want to find the mass of the entire rod. So what we want to think about here is we're wanting to end up with something of units grams. The function f of x is in units of grams per meter, and we're measuring x in meters. So we can set up an integral of the function 1 plus 5x. And we just have to use the context to make sure that we set up the appropriate bounds. So x is measuring the distance from the left end. So if I'm at the leftmost end point on there, we're going to have 0. And we're told that the rod is 3 meters long, so that will give us the upper limit of integration. So now we're ready to integrate. We'll get x plus 5x squared over 2, and we're going to evaluate this from 0 to 3. And 5 times 9, so we will get this. And so if we want to end up with our final answer, again, the units of that are going to be grams. So we end up with the mass of the entire rod. So I wanted to go through an example that's not just looking at things like ending up with grams. So if we go back to this notion of looking at price, of course, this is described a little bit formally in order to make it very clear what we are trying to achieve mathematically. Suppose you're going to buy a piece of yarn that is 200 meters long. So we're going to let the interval here represent the length of that piece of yarn. And let's assume that the yarn is for sale at a price of 5 cents per meter. So that is now giving us, in some sense, the f of x, the density. So suppose we want to set up an integral that represents the price of this piece of yarn. So, of course, we wouldn't need an integral to do this, but let's see what it would look like. We're going to have, in this case, the integrand is constant. So we're finding that no matter where we are on the piece of yarn, the price of that is going to be fixed. And so that's going to be my integrand, is just the constant 5. And now if, again, that's measured in cents per meter. If I want to integrate over the appropriate amount of meters, again, we're kind of set up here telling us the interval is 0 to 200. So we could evaluate that. And if you think about, that's just going to be 200 times 5, right? That's going to just take the amount of yarn we're going to buy and multiply by the appropriate price. So that makes sense. To give this a little bit more, suppose that you're encouraged to buy more yarn because the price is not constant. So the yarn seller is offering a bulk discount in the form of a rebate of the function f of x equals 5 minus 2x plus 2 over x plus 1 cents per meter of yarn. And here x is measuring how far we are from point 0, the leftmost piece on the yarn. Just think about that again, that's reflecting that the more yarn you buy, then we're getting more of a rebate. So given this extra information, now what would the price of this piece of yarn be? So here we have the same length, same amount of yarn that we're purchasing, but it's no longer constant. So you can see that this function here is now going to vary with the point x along the piece of yarn. So I can integrate this to now get the price of the piece of yarn, and it's not simply going to be 5 times 200. So if we integrate this, we're going to get 5x minus twice the natural log of the absolute value of x plus 1. And again, I'm going to evaluate this from 0 to 200. So this gives me 1,000, which is what we would have gotten just computing the first part, minus, though, from this rebate, 2 natural log of 201. Now, that's hard to quantify looking at that. So if you were to throw this into a calculator, it turns out you would get roughly 989.39. And again, my units here would be in cents. So we see that, as expected, we would pay less with this rebate, and this tells us exactly how much less we would pay.